So in the previous video, we talked about what is the domain of a function. Now we are going to talk about domain of operations of functions. So what are the operations of functions? Let's say we have two functions f of x and g of x. F of x is defined as equal to x and g of x is x square. Just like we can add numbers, two numbers, we can subtract two numbers, divide two numbers and multiply two numbers, the same way we can do these mathematical operations on two functions as well. For example, if we want to add two functions, in this case f of x and g of x, then these addition of these two functions would be x plus x square. If we want to multiply these two functions, it would be x into x square, which would be x cube. We can subtract two functions, which would be just as when you subtract two numbers, which in this case it would be x minus x square. And you can divide the two functions as well, just like you divide two numbers. In this case it would be x over x square, and if we simplify it, it becomes 1 over x, and we will have to say that here x should not be equal to 0, otherwise it will generate 0 in denominator and it will make our f over g undefined. Okay, so what we are going to do here is we are going to talk about the domain of operations of these functions. Like what would be the domain of f plus g, what would be the domain of f into g, domain of f minus g, and domain of f over g. So domain of f plus g, f into g, and f minus g will be domain of intersection of domains of f and g. And in our particular case, where f of x is described as x and g of x as x square, so we are going to find domain of f plus g, f minus g, and f into g. So first of all, what is the domain of f? F is x, so the domain of f of x equal to x is all real numbers. We are going to also look at the domain of g, which is again all real numbers because the function is simple, x square. So what would be the domain of f plus g? So in this case, the domain of f plus g would be the intersection of the domain of f and g, since both domains are r and r, the complete set of real numbers. So intersection of these two sets again will be complete set of real numbers. The same way, the domain, this is the domain of f plus g. Here we are looking at the domain of f minus g, which is again the intersection of the domains of f and g, and in this case, in our particular case, this is r. And the same way, the domain of f into g would also be a complete set of real numbers, right? Okay, but what would be the domain of f by g? So it would be the intersection of domain of f and domain of g. In addition to that, excluding all those x's that generate 0 in the denominator. Now in our particular case, the function f is x and function g is x square. So what would be the domain in this case? Domain of f by g. So first of all, we will write f by g, it is x over x square, which gives us x. So f by g is not defined at x equal to 0. So the denominator is becoming 0 at x equal to 0. So that's what we meant when we said that intersection of domain of f and domain of g, but we will have to exclude all those x's from this intersection of the domain that are making the denominator 0. So in this case the denominator is becoming 0 at x equal to 0. Domain of f is R, the complete set of real numbers. Domain of g is the complete set of real numbers, and the intersection of the domains of f and g is the complete set of real numbers again. So from this set of real numbers we will have to exclude 0 because it was making the denominator 0. So we will write domain of f by g is the complete set of real numbers excluding 0. So that's the domain of f by g. Let's look at another example just to be clear on what is the domain of the operation of the functions. So let's in this case consider f of x as x plus 1 and g of x as x minus 1. So let's very quickly check that what is the domain of f. All allowable x's for f of x that give us any number would be a part of the domain of the function f of x, which when we plugged in f of x we get a real number. So in this case all real numbers could be plugged and each real number will give us a real number. And domain of g again is all real numbers, because any real number that you pick and you plug in g of x, you are going to get a real number. And the intersection of domain of f and domain of g is R, because both domains are real numbers. Now if the question is that what is the domain of f plus g, f minus g and f into g, so the answer would be, since domain of f plus g, f minus g and f into g is the intersection of the domains of f and g, and intersection of the domain of f and g is R, so the answer here would be R. So the complete set of real numbers is the domain of f plus g, f minus g and f into g. So now what would be the domain of f by g? So we know that it's the intersection of the domain of f and domain of g, and from this intersection we have to exclude that x that is making g 0, because then it will generate a 0 in the denominator, and 0 in denominator is not allowed. So we know that domain of f is R, we know that domain of g is R, and we also know that intersection of domain of f and domain of g is R. And now let's write f by g as f of x is x plus 1 and g is x minus 1. So what x is making g in the denominator 0? We can see that if by putting denominator equal to 0 we have x equal to 1, it means this 1 is making this denominator f by g, the denominator of f by g 0. So we will have to exclude 1 from the intersection of the domains, and the intersection of the domains is R. So we now know that domain of f by g is all real numbers. That was the intersection of the domain of f and domain of g, and we will have to exclude 1 that was making the denominator of f by g 0. So that's how we find the domains of the operations of functions. So we can just add up the functions, we can subtract functions, divide functions, multiply functions, and then we can find the domains by finding the intersection of those functions. And in a case where we have to find the domain of f by g, we will just have to exclude those x's from the intersection of the domains of both of the functions, which are making the denominator of f by g is 0, or which are making the function g is 0 because g is in the denominator. So in the next video we are going to talk about the composition of two functions. Thanks.